And we're back for another episode of All Things 3D. Today is July 29th, 2014. It's Tuesday, and I'm Chris Kopak, here with my co-host.
Hi, I'm Mike again.
Yeah, and today we have an exciting guest that's remotely joining us, Mr. Slade Simpson from Sculptify. He's the CEO of Sculptify, which is a pretty cool 3D printing company. Maybe tell us a little bit about what you do, Slade.
Sure. Thanks. Nice to meet you guys, and thanks for having me on.
Definitely. Thanks for being with us.
Yeah, absolutely. Excited to be here. So, as you said, my name's Slade Simpson. I live in Columbus, Ohio. That's also where Sculptify currently is. I guess my title is CEO, but I'm more of an engineer. But we all wear a lot of hats right now. We're definitely in startup mode. So prior to founding Sculptify and working on David, I was a design engineer for Honda R&D. I did frame and structure and crash design and part management, that sort of thing. And then I also worked at a place called Commercial Vehicle Group, which did heavy truck design. So I did a lot of rapid prototyping, a lot of laser scanning, 3D printing, and that's where I really kind of started my love affair with 3D printing. So that's kind of my background. I guess a little bit more about Sculptify.
Hang on just a second, Slade.
Sure.
I don't know how you have your camera position, but it seems to be bouncing up and down a little bit.
Oh, really? Okay.
Yeah.
How's that?
Maybe,
Is that better?
I don't know if you're moving your hands, but you
probably. All right.
So maybe minimize that a little bit.
Right. I'll try to do this bounce free. Sorry. So a little bit more about Sculptify. We're based in Columbus as well, because that's where we live, and we're working out of our basements right now. Kind of the funny thing is we've gotten a lot of feedback. You guys look like an established company with your website and your product. Why even go to Kickstarter? Because you clearly have funding or whatever. But the reality is we're working out of a single basement, about 400 square feet right now, and we have a total of 5 people, with 2 of us being full-time and 3 having day jobs. So we've been able to take this pretty far with what limited resources we have. But we started up, March of 2013, so we've been at this for a while. Basically saved every dime I could from my previous jobs as a design engineer in order to work on this full-time with little to no income. So, and then the co-founder, Todd Linthicum, I met him in college, and he was doing a robotics thesis and that sort of thing. So that's his background. He's also a mechanical engineer. Then we have 3 additional people that are super bright, and we've been able to get pretty far. So that's kind of the abridged version of Slade and Sculptify, I guess.
Awesome.
Yeah. Well, you made a good point there that with the tools available to you now in making videos as well as presentation on the web, it's real easy to create a very professional look. But you also have a very professional looking printer there too. So
Thank you. It's been a long process to get it to where it is, so I'm glad that we're getting good feedback on it.
So let's move on. I
Sure.
kind of understand the word Sculptify, but why did you use or choose the word David as your choice of the printer's name then?
Right. That's a common question because it's so different, I guess, than what's currently out there. So with Sculptify, the thought behind it was, 3D printing is just as much art as it is science in our minds. It takes a certain amount of creativity to work with it. That's why we kind of like Sculptify. But along with that, with the sculpture and the art, David's a very famous sculpture by Michelangelo, and we just we liked that, and it was really identifiable. Most people know a person named David. And there's a lot of bots and makers and those sorts of names kind of flooding the market. So we just kind of wanted something that set us apart. We feel like we kind of have a different mentality when it comes to this. So, and then it's also, a lot of people have pointed out, and it really wasn't our intention, but it's kind of interesting, is like the David v. Goliath type of analogy, which is kind of cool, I guess. Not what we set out for it to be, but if it works out, great, you know.
Sure.
No,
so that's
and
kind of,
yeah, that was my thoughts as well. Is that one, either it was David from Michelangelo,
Yep.
or the David or Goliath, and obviously both of them seem to fit. So that's
yeah,
cool.
yeah.
Yeah, well, and you know, so there's this really famous guy, Cosmo Weinman, I believe his name is, and he scans all sort of really famous museum pieces.
Mm-hmm.
You've probably seen his work. He does like the Winged Victory and things like that.
Okay.
But you should definitely get in touch, because I don't know if he's done David, the Michelangelo piece,
Mm-hmm.
but you should, you know, I'm sure it's on his list of things to do, and I'm sure if we shared this podcast with him, you know, maybe we could get him excited
that'd be
excited
great.
to go. Yeah, and then you could have a model of David, you know, for your,
absolutely.
Chris, maybe I'll go ahead and see if we can get him on in an interview, and then
yeah, that would be great.
Close the loop for this. So.
There you go.
So let's mention another word, flex. You know, we've heard of FDM, FFF, or at least in my case, flex. What does that mean?
Well, I get the kind of saying we use around here is David is FDM or FFF from the nozzle down, so it prints exactly the same, but the material delivery system is different. So we didn't really think it was fair to use FDM or FFF for what we're doing. So we kind of came up with flex, just a nice little acronym for fuse layer extrusion. And what kind of is what we like about it is that, you know, we think our system is really flexible. So the flex kind of fits along with that. So it's just kind of a nice little play on what we're doing, I guess. But like I said, more or less from the nozzle down, we're looking at, you know, very similar to FFF or FDM technology with it.
Awesome.
That's kind of my thoughts as well, as you know, it's a flexible system. So that kind of gets into the next item, since it is a flexible feed. You feed these rabbit pellets, right?
Yep. Yeah, we do. Yeah.
Prints alfalfa.
It's biodegradable.
Right.
No, but on that note, you use plastic pellets, and from my crude or basic understanding, pellets are what's used mostly to create actual plastic filaments. So they go through this extruder process in order to create that. So you've kind of skipped that step with your process. You can take those raw pellets and just kind of put them into the chute and print away, right? So why don't you kind of talk about, you know, as much as you can, what makes yours unique in that principle? I mean, it's not just a funnel, I'm assuming, right?
Right. Well, it's a relatively complicated system, but it's inspired by industry technology that's out there in the plastics industry. So it's tried and true, but it's been modified, and not necessarily modified, but, you know, redesigned to make it 3D printing friendly. So the reason we picked pellets is, you know, we found ourselves kind of limited with filament. When I've owned a personal 3D printer for a few years myself, before David, and you know, wanted to print in a lot of different materials. And, you know, filament can be expensive, especially from, you know, larger companies, and a lot of companies are getting into the proprietary side of things, which inflates cost a lot more and kind of limits you. But we see a lot of potential in tons of different materials. So anywhere from the prosumer and enthusiast that just wants to print something flexible, reliably, to the rapid prototyping house that wants to print a part for a customer that is actually the material that they're going to use in mass production. Because right now, kind of out in that sector, like the rapid prototyping houses, the small businesses, entry-level commercial, they use 3D printing really for geometry and tolerance testing, more than the actual material and the feel of it and all these, you know, all that comes along with that. So we thought that opening up material options was a really great way to push 3D printing forward. So that was kind of the main driver behind it, is material options. Now, some nice side effects that come with that, there's a reduced cost, because you're skipping a lot of steps in between pellets and filament. And also, the closer you can get a material to being its virgin resin, so unadulterated, no contaminants, the better. You're going to get more consistent prints, more consistent material properties, because once you extrude some materials do change, even though they are thermoplastics. So the closer we can get it to its true form or its unadulterated form, we think the better and higher quality it will be. And also using pellets kind of skips the tolerance issues and air bubble and contamination issues with that are common with filament right now. So the main real reason behind pellets is just a wide material library. We think that is kind of the next step in the technology to kind of branch out and hit a lot of new applications. So that's kind of where where it came from and where it's evolved to.
So pound for pound, pellets, how do they stack up cost-wise? Is it a half the cost?
Well, that's kind of hard to answer in one sentence, but it depends where you're getting your filament from. Of course, there are some spools out there that are $25, and then there's others from, say, 3D System that are $99 somehow. So there's kind of a wide swath there, but in general, it's around 10 times less. So they're upcharged about 10 times what it costs the filament manufacturers to actually buy the material. So that's paying for engineering to figure out how to extrude it well and consistently and spool it, and paying for the spools, paying for the shipping, all that. So that's all. There's tons of layers of cost in there that we're hoping to skip. But also the cost of pellets changes a lot with volume quantities. So the more you order, the less expensive it is, and that's very common. But that's kind of the idea behind what we're doing, is if we can find a material that we really love printing with and the community loves printing with, that we can buy it in bulk and pass that savings on. So that's kind of the big idea behind that. At the same time, we're not going to make any of the materials proprietary. We're fans of open source, and we think it's good if people have the option to get their own materials and give it a try. So there's a lot of cost savings in there, and we're going to try to pass on as much as we can. We still have to run a business, but
sure.
There will definitely be savings in there for the user, and free them up to experiment a little bit more, because the hit on your wallet won't be so bad if a material doesn't end up working out how you want it to, or is more difficult to print with than you want it to be.
Right.
So I've got a couple of questions, but before we move on, Slade,
Sure.
I've got to be the producer here. Move your mic away from your mouth a little more. You're getting some
Sure. How's that?
A little bit further in.
Okay.
No, yeah, there you go. Let's go ahead.
Okay, great.
Good. Thank you. So my questions, and I'll just add it. Okay, so now that we have all these pellets in this funnel, what if I wanted to change the color or go to a different material? How do you evacuate the chute, as I called it, and put a different material in there?
Right.
With standard filament, you just reverse the process and then put in a new one. So
right.
How do you do that here?
So there is a lot more material in the system at one time than a typical FDM printer. So this is a question we do get a lot, and we haven't had the huge opportunity to really explain ourselves on it. So basically, we want to make an algorithm that tells the user through their open source GUIs or whatever how much they need to put in for a particular part. So say you want to print one part out of PLA. How many pellets do you need to put in? And right now, the main idea is to use a scoop method, just kind of like coffee, essentially, or by weight. The scoop's a little easier for your everyday consumer, I think, so that's probably the direction we're going to go. But you'll say, I want to print this part. Okay, put in 5 scoops of your PLA pellets and go to town, essentially. Or if you're going to be printing a lot of the same material, you fill up the hopper and print away. So the idea is to not have to evacuate, because it can be a pain. And if you want to switch materials, since you only have what you need in there, you basically just extrude the rest out and pour in your new material, let it feed through the system, get warmed up, and you're good to go. It usually takes 2 or 3 minutes probably to change materials. So that's the current process for our prototype right now. I mean, hopefully we can refine that process further and further so that, after Kickstarter we can have it really well figured out. But the process works right now as it is.
Yeah, well, you're putting a lot of the burden back onto the user to make sure that they have enough material in there. And knowing me with coffee, I always run out, so I don't think I'm going to be a great candidate for this thing. But the other point is, you say measure it and then extrude the remaining part. So there's no way to evacuate the material. So if I wanted to quickly, if I'm running a business, which I do, somebody says I want something in red or something in white, I mean, I've got to do this within a minute or two in order to make that switch. Or in the case I do lens caps, and one person may want a translucent version. So if I want to move forward with David, I see that cycle being a little bit slower, or I've got to do a lot of forethought as far as what material. So so I could see if you're doing a batch of things, but if you want to do some custom stuff, it may be a little more difficult.
Well, we plan on making it as easy as possible. That's our main goal, is to make it the most capable 3D printer, and that means not having to tinker with it a whole lot. And it doesn't take long to evacuate the chamber. And still, even when you're switching colors on an FDM, you still have to extrude a little bit because there is residual left in the hot end. So it's really the same idea. It just happens that volume's slightly bigger, so it might add another minute to the switch time. But it shouldn't be anything that's holding people up. So
yeah, the other thing, in my process, I have all my filaments up above the printer, and then I can just roll them in. So I could see maybe a bunch of little hoppers with little tubes that go into that funnel. That's what I'm going to do. Creative juices are flowing here.
I think that there's a lot of different ways to go with how people use this, and that's what's really exciting. So we'll have people with the giant, hopper arrays that can feed in different colors and all that. But we're excited to see how that goes.
So you did say you guys are fans of the open source movement. Yeah. So maybe we could go in a little bit on that. So are you planning on open sourcing any of the design, any of the software?
Yeah. So we will have open source software, or alternatively have it work with current open source software. And also our electronics, we're planning on having open source, because right now we're 5 people, and the community is so big and so passionate about it that there's no reason to compete with them or to close it down. I think that if we can all work together, that's awesome, and really push this interesting new hardware and new technology very far forward. So we want to. It really depends on how successful Kickstarter is, really.
Sure.
If it's really successful and we can hire additional great people, and we could make our own software, and ideally we would. But if not, then we can make it work with existing open source software out there. So that's what we're using right now, and that's our plan moving forward. So we really want to try to stay away from locking it down, because
there's some great open source software out there already.
There really is.
My whole thought is, with a lot of these 3D printers, I run an open source 3D printer in conjunction with my production equipment. And what's really nice is, like what Mike was saying, is if you wanted to make a new hopper that you wanted to integrate into your system, to already have the drawings already done up, in an assembly format that you can quickly CAD up, something compatible without having to take the calipers to the machine or anything.
Right.
So I think there's some sort of balance that we need to find between open source and proprietary that still in the 3D CAD world hasn't yet come about. But
it's really difficult, because the way the U.S. patent system works makes it very difficult, and the way that these bigger companies like to throw around their weight also makes it very difficult. So they, a lot of these smaller companies are pretty much scared. You're scared to implement all the technology you want to, because you think you're going to be stepping on somebody's toes and they'll bury you in legal costs. And that's a terrible way to start a business, but at the end of the day, it does have to be a business. You have to make money, and you can't have people underselling you using your technology. But like I said, we want to open it up as much as possible. We think that that's the best way to go with things. So, we're going to do what we can to, like you said, it's the balance. It's the balance between having having your technology and having it work for you, but also being open enough so that people can really push it forward. So that's something we're really focused on and trying to figure out as we go. So
cool.
Well, as many in our audience know, I go back a few years, decades, maybe centuries. But back if we use the analogy of the computer era, a lot of companies, commercial like Commodore, Apple, they created products that were obviously based upon their own patents and their process, but they did allow design specifications to be released so that you could design like the electrical connectivity for the interfaces, the physical dimensions, and let's say in the case of the Commodore 64, or even the Apple II, it flourished because of that. And people were able to make product. So, I mean, there is a balance there where you can still keep, you can't make a direct copy of something, but you can build accessories upon that because the specification. So I assume that's the direction that you'll be going, right?
Yeah, that's the hope right now, yeah. So.
Okay, let's move on to our next question. Other than this unique way of putting material into it, you have a really clean finish.
Thank you.
As it's identified, it's made out of aluminum. So, with all the different types of materials out there, acrylic, plastics, melamine, why did you choose aluminum? In fact, I know there's some that are made out of steel that weigh a ton. So why?
Well, that's the reason we didn't use steel. We're trying to keep weight down as much as possible. Shipping adds up. So if we wanted to make an entire shell, and this product is relatively big, so if it were steel, that might be bad news for the end user, paying for shipping. But we wanted something that was really high quality and that matched the ability of the insides. We have great insides. We have the lead screw system. We have great electronics that we're developing. This new technology that we're really proud of, and we wanted people to see that when they look at the printer itself. So we want people to be proud of what they're owning. In addition to that, aluminum allows for increased durability. It's still light, but it can still hold up to a lot of abuse. So that's kind of the main reasons that we chose to go that route, and we really love how it looks more than anything else. So.
No, and I totally agree with that. And you do identify that you're using aircraft aluminum, which obviously is a higher grade. So I think it's going to be a win-win, and it looks like your framing process looks structurally sound. So kind of moving on with the engineering of this.
Sure.
Yeah, let's see, I'm going to jump right into the lead screw mechanism that you talked about earlier. That seems extremely unique, but one of the things that I noticed was with other lead screw designs, mainly that they're in the vertical areas, that they're slower. So how did you get around that?
Sure. So a lot of existing vertical lead screw orientations have kind of low lead screws. So they're like TR8 times 8s. So for every revolution, they're going 8 millimeters, which isn't much. So kind of what we did, and our Zs are similar to that because you don't really need high speed in the Z unless you're doing something really crazy that I can't really picture right now. But for the X and Y, we chose a higher lead. So you're going 20 plus millimeters for every revolution of the motor. So it's kind of a balance between precision and speed because our print bed is 8 by 9. So we're talking about an inch per revolution. So we're talking 8 to 9 revolutions of a stepper motor to get the entire distance of the bed. So it still allows us for some good speed. Something comparable to the bigger guys out there, your MakerBots and Ultimakers. Well, Ultimaker has really high speeds, but so we want to be competitive as possible. But I think that where the lead screws really shine are the precision. And those coupled with, we're using some different controllers with our electronics. So that allows us to get a little more precision even with some different microstepping settings and managed stepping. So.
Yeah, you mentioned that you're using what, 1/16 or
That's at minimum. We've been actually trying some higher ones without sacrificing torque. So those specs we put on there are our conservative specs right now, ones that we know we can stand behind. So
are you getting your own? Are you manufacturing your own lead screws, or these? No. This is
actually, yes, not in house, but yes, they
got it.
They aren't necessarily off the shelf. I'm sure you could find them, but they are.
Right.
These particular ones in our prototype are custom to our machine.
Got it.
But like I said, I'm sure that they're available out there somewhere. You just have to know where to find it. But you're not gonna. You're not necessarily gonna find it at a Make Mendel site or something like that.
Yeah, because I noticed a few months ago Thompson lead screws. They brought out some new lead screws that were supposed to be, but there's no place. Yeah, it's more of like a build to function type lead screw. It's not. Right. They don't have like a common size that you can just buy one off the shelf and then design your machine around one. So this is a real interesting approach to the whole design, is having your own lead screw design.
Yeah,
we obviously wanted that balance, So sorry, Michael, go ahead.
Oh, that's okay. I mean, obviously that's. You needed to do that, and my original question is, how do you get the performance? And you explained it. So are these also machined out of aluminum, or are you?
So our lead screws are steel. We wanted them to really hold up, and right now we're using plastic POM bushings for those, so it's self-lubricating and it can hold really nice tolerances. So that's kind of where we went with that. We went with the steel lead screws. So.
Okay, so I'll jump back up to my previous question. So we've kind of talked about the motion mechanisms as well as the hopper. What about the hot end portion of it? I noticed in your material, your description, that you include 3 different diameter hot ends with the package, and that you also have a wide range of temperatures, and which means a wide range of materials. Are these also off the shelf, or have you kind of customized that direction as well?
We actually had to customize that as well, because the way our system is oriented and how it delivers the material to the heated portion, it just couldn't be off the shelf with how we're doing it. But we want to offer as much versatility as we can, so we're offering with the printer 3 different size nozzles, just because different materials require different nozzle diameters for optimal printing. But our temperature range right now, what we're comfortable with, is around 330 C, which is pretty hot, and will pretty much extrude any thermoplastic anyway. So we wanted something that was reliable and could really hit those high temperatures and maintain them well, so that people weren't limited to what they could print.
So how are you controlling the temperature from moving up the frame or the mechanism itself, which is a problem with other designs of creating a very hot end? How are you handling that, or do you want to kind of keep that hush right now?
I'll do it. I'll kind of give half an answer, I guess. We're isolating it as much as we can, and it's worked out pretty well. And we have some ways of cooling it that are helping as well. But right now we're still kind of optimizing that, but we haven't had much trouble, keeping the heat where it needs to be. So.
Yeah, and you mentioned you can change out the hot end nozzle. Is that fairly easy, or?
Yeah, absolutely. It's just unscrewing with a wrench and putting a new one on. It's just the little nozzle tip that comes right off, and you put whatever size you want on. And as we grow, we can offer more different types of nozzles with different heads and different profiles and that sort of thing potentially. So we want to be as easy to deal with as possible and make the printer as capable as possible. So
yeah, that's, I think, extremely important. I've used some materials. There's a PET material out there that requires a very large nozzle, but depending on the printer, that's difficult to do. So they get around that by doing some virtual changes and slowing down the extrusion process. Which, to me, if you just had a nozzle that was large enough, you wouldn't have to deal with all that. So obviously, you're addressing that issue. So that's a good thing. Chris, you got something while I try and
Well,
move on to the
yes,
next.
yeah. So I see all these materials
Mm-hmm.
you're offering, and I notice here. Let me pull this up here, and I notice like hips. You've got all these materials on here.
Mm-hmm.
Um, so what are you using for like a bed? What are you like? What are you using as far as a to control your heat on the bed and to
Right.
adapt to all these materials?
Sure. So these materials are ones that we are testing and optimizing. We're going to add as many materials as we can, as long as we can stand behind them. So these particular materials are ones that we have samples for and that we're currently trying to optimize for the machine. In terms of controlling heat, we're working out a heated bed. This kind of goes back to the patent thing and the whole fuss with Stratasys, and I actually forget which company it is now, but it could affect every company. There was a lawsuit, I believe it was last year, about heated beds and enclosures and that sort of thing, and it's kind of scary. So we're trying to see if that benefit makes sense. Of course, we want the printer to be as easy to use as possible, and a heated bed does help with that. So we're working on getting a heated bed, but the build platform itself is aluminum right now, and that's for a few reasons. Is it resists warping and scratching, and remains perfectly fat, pretty much for the entire use of, or the entire time you own the printer, in theory.
Yeah.
So
I may have
yeah.
spaced out there, Slade. Did you identify the material of your heated bed, or?
No.
Aluminum.
Right now it's aluminum. Yeah, it is aluminum. I don't remember if that was on the spec sheet or not, but.
So do you plan to apply a surface? There's a lot of new materials are coming out that you can apply to it that people are working with. I'm using something. What's the name of it? Build tack, which seems to work pretty well. So, and you just lay it over the top of it. So I don't know if that would be necessary. I do have an aluminum bed on one of them that I've inverted the heated PC board, so I'm actually printing on that, and it works really good. So.
Really? Okay. Yeah. So right now we just have a sandblasted aluminum surface, but we're going to try different finishes to see what's best. We've been using things like Kapton tape and like ABS glue and that sort of thing for getting optimal sticking, I guess. But it's still something we're working through. This, at the end of the day, is still a prototype, and we're still working through a few things, but we've gotten really far with it. So
we'll look into Build Tech, and then there's somebody out at Kickstarter that's come out with a new material as well that maybe you can join up with. That might be useful for that. I kind of swear by them. The only thing is you better make sure that you've got your level set beforehand, because they're kind of a soft material, and you start getting depressions in it, and it shows up in your print. So
gotcha. Okay.
Yeah. So. But other than that, they work really well. I use a little bit of, depending on the material, if I'm using PLA, I put a little glue on it. Heated bed at around 50, 60, and I have no problems at all with larger items now, so it's pretty good.
Great.
So moving on to the next item here, and we're on, because Chris just talked about the hot end. So I noticed that your printer doesn't have an LCD panel. So I'm assuming it also doesn't have an SD, because I didn't see that in the specs.
Right.
And you just mentioned USB. Can you kind of explain why you didn't go the direction many other printers? And
Sure.
I've made sure that on mine that I have that capability, because I'd like to keep them independent. So.
Right now, it's really a matter of resources. USB is the simplest for us right now. Wireless connectivity would be great. Printing from the cloud's awesome, and we want to go that route at some point. But like I said, we're a team of 5 with next to no money at this point. After using it all to get the hardware where it is right now and the electronics, but it's not, an LCD panel is not something that's out of the question. And if there's an overwhelming desire for it from the community, and if we think that it really does make sense and makes a big difference, then that's something we could add.
Stretch goal.
Yeah, exactly.
And I would strongly encourage moving in that direction. A few of them create an umbilical cord version of it, so you might look at that.
Right.
But, I find that it's important to have that independent capability. Or I don't know how fast or what your controller board is, but if you've got a fast USB, a lot of them are only using 115 baud, which is super slow. But if
Right.
you're going more at a USB speed, like the Form 1, you can
Mm-hmm.
download your file to it and then disconnect, which is a a thing. And PCs aren't that difficult. I have one that's specifically set up to control my printers, so
Yep.
it's not an issue. And there's a few people on Kickstarter that have controller software now, so that maybe you can team up with them to create a cloud functionality and not
Right.
have to invest the money into it. So you may want to talk
Definitely.
with them too.
Okay.
Send me an email later on, and I'll send you some of
Sure.
the links if
Yeah,
you
and
want.
Steve Hernandez, the creator of Creation Workshop, it's a real common software, real great software for SLA DLP printing.
Okay.
He actually is trying to work out how to monetize and set up a Raspberry Pi host. So Pi host type software. So look out from him. It looks like he'll have something probably within the next year, I would say.
Okay. Great. Yeah.
It's a standalone Raspberry Pi that goes with pretty much any USB 3D printer, and it's capable of being the host. So, which is a cheap
Okay.
alternative to the SD connectivity.
Definitely. Yeah. Definitely.
As mentioned, there are a couple of companies doing that right now, and one of them is on Kickstarter. I still think or actually they just closed down and they were successful. So I'll send you a
Great.
link to them as well.
Okay.
It's somebody that we've used before, Chris, and I just can't remember their name now. But that's a good segue into the next item, which is, what kind of software are you using? Or can I use my favorite slicer?
I guess I kind of touched on this earlier, but right now we're using existing open source software out there, and we want to keep it that way. We want, regardless whether we develop our own or not, we want it to be open source. So in an ideal world, we'd have both, where we would have our own, but it would also be compatible with everything else out there. With our current resources of 2 programmers, I don't think we'll be writing our own slicer per se. Possibly a GUI that maybe utilizes slicer itself, but we want it to be as capable as possible, or compatible as possible with every open source software out there. So that's the goal.
Well, there's obviously 2 directions you can go with. Cura, which is what I use with the Ultimaker, plus I also use it with the Delta printer. I like very much, and it works well, and you can pretty much conform it to any printer that you want, just create a profile for it. The other one is Simplified 3D. There's a cost to that, but I think the guy is working with a lot of people to bundle it, so that might be a direction to go with too. And that's a very polished. In fact, they've just made some new changes to the way it actually builds layers. That's a little different and I think more efficient. So you might want to look into that one as well.
Okay, great. Yeah, absolutely.
Chris, you want to add to that? If not,
No, I definitely look forward to seeing this printer in action. Are you going to? So you're going to launch it on Kickstarter, and any plans to show it off live in person at any shows, maker fairs?
We would love to. We talked about doing Maker Faire in New York, but unfortunately we don't have the money for a booth right now. So we're about as lean as possible.
That's a good place to be. I run my business. I'm a one-man show still. I'm about 2 years deep. I'm a little over 2 years deep. Wow. And it's an exciting place. You're on the frontier. It can be a little stressful sometimes, when you're. So, but just keep your eye focused on the prize, which is ultimately the prize is bringing the 3D printing to the masses. Making the world better through technology. Enabling people to make things again.
Absolutely.
Rather than just being consumers that are helpless and at the disposal of giant corporations that manufacture everything for you.
Exactly.
Now, this is empowering, and it's an empowering movement for everybody. So, there's a lot of people out there, they don't even know they need 3D printing yet. But they're figuring it out. So, a lot of people are going to need your printer, and they don't even know it yet.
Yeah, we're really excited about where it can go. I think that, we all think that the multiple materials and, so many possibilities with all the materials and different grades out there, it can really get into a lot of new applications that people, you don't know what you don't know, right? So once it starts branching out into new applications and new uses, people will find another application and another, and it will just build and build. And that's what we're mainly excited about, is to really see if our technology can push it forward into that. Because to really get into the mass, I think that you have to be able to print more than one or two materials. Not everything in your house is made out of PLA or ABS, and there's a reason for that. So, well,
mine is no.
No, like the thought of being able to print HDPE finally out of pellets. I mean, come on, that just sets you aside right there. I mean, here you go, Nalgene.
I can just imagine a creative artist now coming up with his habitat made completely out of PLA, ABS, or materials that you can 3D print.
Sure.
I wouldn't do that, but somebody will. All right, so this leads to the final question.
Mm-hmm.
I don't know. I feel like a game show now. And
How much?
for the final prize, how much?
Well, we're still working on cost. We want to get it as low as possible, obviously. We want it to be as accessible to many people as possible. But we are planning on being competitive with MakerBot. We think that that's a good price point for how premium our printer is and how value it. The Rep 5, so Generation 5 replicator, their newest. Because we think that we're comparable with that in terms of specs. In our opinion, which is a little biased, we're higher value because of the materials. But
well, exactly. I mean, you can support multiple materials. And what's interesting is that I was looking at them for a while, and I just realized they only have one that can support more than one material.
Yeah,
and that's the 2X. Everything
really
else,
closed it
including
down.
their big ass one, which is close to 70, or was it $5,600?
Yeah, it's north of 6, I believe, 6,000.
Only
I think,
does
so.
PLA.
I know, it's
I don't
insane.
even have a heated bed. I mean, they say they have a heated chamber, whatever that means, but no heated bed. I was like, huh?
Yeah,
how do you get away with a price like that? Well, not to bash MakerBot, but more power to people like you, Slade, who can put out something that does something unique and can use a lot of materials. PLA doesn't make the world spin.
Right.
All right, so you have the last word, Slade. What do you want to tell our audience, and where and when are you going to run this Kickstarter?
We're hoping to get to Kickstarter. The current plan is in August, and I think we're going to be able to stick to that, looking at the timeline. We actually started filming this weekend, so it's exciting times for us. And we're happy with all the feedback, and humbled by it. It's been insane, honestly. So we're excited to get David out there and see what people can do with it, and we're really excited to share the future of this with everyone. So that's all I have.
All right. Well, we wish you the best of luck, and
Thank you.
I think you're going to do super well on your Kickstarter.
Thank you.
And thanks to all our listeners for joining us on another episode of All Things 3D.
Thanks a lot.